This video we will focus on analysis of function 2. So in this slide we will look at asymptote. So an asymptote is a straight line that a graph approach without touching. So this is the keyword, approach without touching the line. So vertical asymptote, and we have two asymptotes, which one is vertical, another one is horizontal asymptote. So in order to find the vertical asymptote, step 1, we will let the denominator equals to 0 and solve for x. So we will let the denominator equals to 0. Then we will analyze the asymptote by approaching the value of x from left and right hand side. This is the analysis. And for horizontal asymptote, we will find the limit of fx when x approach positive and negative infinity. So how are we going to solve this limit? So we divide the numerator and denominator with the highest degree of x in denominator. Let's look at one example. So let's look at example 1. Consider the function of fx, where fx is a fraction, 5x over x minus 2. First, find the x and y intercept. Second, find the vertical and horizontal asymptote, including its analysis. So find the interval where fx is increasing or decreasing. Find the interval where fx is concave up and concave down. And finally, we will sketch the graph. So first, if we look at A, again, we will try to find the x and y intercept at x intercept. Y is equals to 0. In this case, y is referred as fx. So 0 is equals to 5x over x minus 2. If I multiply x minus 2 to the right hand side, it will become 0 is equals to 5x. So x is equals to 0. Second, at y intercept. So at y intercept, x is equals to 0. So our fx will become 5 times 0 over 0 minus 2. Against here, we should have 0. So this is x and y intercept. Next, we will look at B. Find the vertical and horizontal asymptote. So for vertical asymptote, we will let the denominator, so this is the denominator, equals to 0. So let x minus 2 is equals to 0. X is 2. So this is our vertical asymptote. Next, we will try to find the analysis. So limit, let's say when x approach 2 from left hand side, for the function of fx is equals to limit when x approach 2 from left hand side, the function is 5x over x minus 2. If we try to substitute, let's say we have the interval. Here is 2. Let's say we try to substitute a value that very close to 2. For example, 1.999. So this is quite close for value of 2 from left hand side. So here, let's say I substitute into x. You can use your calculator to substitute. So if I substitute into x for 1.99, the value is, say, substitute in x, 5x. If I substitute into x, so this is x minus 2. So if I substitute 1.99, the value is negative 9,995. So we can assume that this is negative infinity. So if I start to substitute next, let's say I look for the example, I show you an example, how we're going to substitute. So when x is equals to 1.999, so the limit Now I will substitute 5 times 1.999 divide by 1.999 minus 2. So from here, I should have negative 9,995. So I can assume that this value is, if x is closer, getting closer with 2, this value will approach negative infinity. Same as the second, let's say, limit when x approach 2 from right hand side for the function of 5x over x minus 2. Again, let's say we have the value of 2, approach from right hand side. I try to substitute 2.001. So if I try to substitute 2.001, so 2.001 minus 2, so here I should have 2.001, I should have 10,005. So I can assume that limit when x approach 2 from right hand side for the function of fx is positive infinity. So this is the vertical asymptote and the analysis. One is approach negative infinity, another one is approach positive infinity. Next, we look at the not C, but we look at the horizontal asymptote. So for horizontal asymptote, we will find the limit for fx when x approach positive or negative infinity. So where our function of fx is 5x over x minus 2. So 5x over x minus 2. So from here, I will divide by the highest degree. In denominator. So in this case, I will divide all the, so in this case, I will divide x, the highest degree of x is x, so I will divide by x minus 2 over x, 5x over x. Next, I try to simplify. So here is 5 over 1 minus 2x. If I try to substitute infinity, so here suppose will become 0. So from here, I will have 5 over 1, which is 5. So our horizontal asymptote is y is equals to 5. So this is vertical. So our vertical asymptote is 2 and our horizontal asymptote is 5. So next, we'll look at C. Find the interval where fx is increasing and decreasing. So for C, we need to find the first derivative. So since our fx is equals to 5x over x minus 2, and this is a fraction, we will use quotient rule. F prime x is equals to vu prime minus uv prime over v squared. So where our v is x minus 2, u prime differentiate 5x, I should get 5 minus u 5x, v prime is 1 over v squared, so it's x minus 2 squared. So I try to expand 5 times x, 5x minus 10 minus 5x over x minus 2 squared. So 5x minus 5x, this is negative 10 over x minus 2 squared. So next step, we will try to find the critical value. So next step, I will let f prime x is equals to 0. In this case, will become negative 10 over x minus 2 squared is equals to 0. We try to find the critical value. So for the numerator, so denominator since it's negative 10, so we just focus on denominator. So x minus 2 squared is equals to 0. X minus 2 is equals to 0. X is equals to 2. So we only have one critical value. So next critical line, since we only have one value, we need two intervals. So the first interval from negative infinity to 2, second interval 2 to positive infinity. Next, we will draw the table. Let's say this is our table. First is interval, test value. Next is sign of f prime x, where our f prime x is negative 10 over x minus 2 squared. So this is our f prime x. And then the interval is from negative infinity until 2 and 2 until positive infinity. Let's say the test value here is 0. Here let's say is 5. So here the numerator is always negative. The denominator, because of power of 2, you can try to substitute 2 into x. So this is positive. So here is negative, where 5, so 5 is negative. Here if I substitute 5 also is, if I substitute 5 here is positive. So it's negative. You can see that, you can notice that in this interval, we only have negative sign. So means that decreasing interval is from negative infinity until 2 or 2 until infinity. Whereas for increasing interval, we can write as none. Does not exist. So it's none. It doesn't have increasing interval. So this is for C. Next, we look at D. Find the interval where fx is concave up and concave down. So D, concave up, concave down. For concave up, concave down, we need to find the second derivative. Let's say before this, our first derivative is negative 10 over x minus 2 squared. So since our numerator is a constant, we can skip the quotient rule. So what I do is f prime x, I can write in the form of negative 10 times x minus 2 power of negative 2. Here comes the second derivative, f double prime x. So first, we will differentiate the index. Second, we will differentiate the bracket. So first, I bring negative 2 to the front, multiply with negative 10. So here is 20, x minus 2, power of, reduce the index by 1, power of negative 3 times 1. So here is 20 over x minus 2 cube. So this is the second derivative. Next, I will let our second derivative equals to 0. Means that 20 over x minus 2 cube is equals to 0. So next is inflection. Since the numerator is 20, so we just concentrate on the denominator. So x minus 2 power of 3 is equals to 0. X minus 2 is equals to 0. X is equals to 2. So for inflection line, we only have one value, which is 2. Then we need 2 intervals. Next, we construct the table for the second derivative. So here is our table. Let's say larger face. So this is our table. So first is interval. Second is test value. So third is sine of f double prime x, which is equals to 20 over x minus 2 cube. So the first interval is from negative infinity until 2. The second interval 2 to infinity. Based on this inflection line, let's say test value, here is 0. Here is again is 5. So for second derivative, the numerator is positive. Let's say I substitute 0 here, I'll get negative. So here is negative. Next, I substitute 5. The numerator is positive. The denominator 5 minus d, this is positive. So here I should have positive. So finally, we try to find the concave up and concave down. So concave up, we will choose the positive sign. Therefore, let's say right here, concave up is equals to 2 until infinity, whereas concave down is equals to, choose the negative sign, from negative infinity until 2. So this is concave up, this is concave up, this is concave down. So next, finally, let's say E, sketch the graph of fx using the above information. So let's say we try to sketch the graph. Duplicate. So try to erase this page. Okay. So we will sketch the graph. The final part of this question is to sketch the graph. So let's say I try to rewrite the information that we have. A, the intercept is 0 and 0. So let's say x-intercept, y-intercept. So try to rewrite the information. X-intercept is 0. So x-intercept is 0. Y-intercept also equals to 0. So this is the information from A. Let's say the information from B. Our vertical asymptote x is 2. So vertical asymptote x is 2, and the analysis limit when x approach 2 from left for the function of fx is negative infinity, from right positive infinity, left is negative infinity, and for the right hand side, when approach 2 from the right hand side, is positive infinity. Then our horizontal asymptote. So for our horizontal asymptote, is y is equals to 5. So is y is equals to 5. So now we try to sketch the graph. Let's say I have a y-axis, and then I have an x-axis. So our vertical asymptote, so this is x, this is y. So our vertical asymptote is at x is equals to 2. So let's say here is 1, here is 2. So x is equals to 2. So let's say it's this line. X is equals to 2. So here is 2. This is our vertical asymptote. And our horizontal asymptote is at y is equals to 5. Let's say here is y is equals to 5. So this is our horizontal asymptote. So here is 5. So first we have to know that our x-intercept and y-intercept is in here. So by referring to the vertical asymptote, let's say limit for x fx when x approach 2 from left. So this is 2, and here is the left hand side. So here is the, let's say right, here is the left hand side. So at limit for fx when x approach 2 from right. So here is the right hand side. So this is our asymptote. Our graph will only approach the asymptote without touching the asymptote. So asymptote is the straight line. The graph will approach without touching. So let's say I start to sketch our graph. When I approach 2, this is 2 from left hand side. So here is left hand side. So when I approach 2 from left hand side, my graph will approach negative infinity. So here is negative infinity. So this is negative infinity. When x approach 2 from right, so we cannot approach from here. So because it will cut the asymptote. So here is positive infinity. So when x approach 2 from right hand side, our graph will approach positive infinity. So this is the second graph. Let's say here is the vertical asymptote. So this will be our graph.